All right. So to record, so when we multiply this out, so when I square x plus h, when I do x plus h squared, so now that's going to give me the limit as h goes to 0. That's going to give me 4. This multiplied as x squared plus 2xh plus h squared. So I end up with x squared plus 2xh plus h squared minus, and I'll go ahead and distribute this. I get 3x minus 3h plus 5, and distribute the minus sign, so I get minus 4x squared minus 3x plus 5 all over h. Yay. Guess I should have gone ahead and distribute that top part. So that's going to give me 4x squared plus 8xh plus h squared, and the rest of the stuff. All right, now let's see what cancels. Well, let's see. When I look at this, the 4x squareds cancel, the minus 3x cancels, and the plus 5 and the minus 5 cancels. All right, so if I write down what I have left, I have the limit as h goes to 0. Oh, 4h squared, yes. So now I end up with 8xh plus 4h squared, and I could get a minus 3h, and that's all that's left. Now let's talk a little bit about how limits work, right? Or how all of these work. Now this one's a little different in that pretty much all the other problems I've given you, it's x goes to 0. This is h goes to 0. So if h goes to 0, and that gives us 0 over 0, there's got to, an h has to cancel out. Another reason h has to cancel out is I want to make sure I don't get 0 over 0, and if the h goes away, I'll pretty much guarantee I won't get 0 over 0. But now if I look at it, I can see there's an h in common at the top. So when I rewrite this, that's going to give me the limit as h goes to 0. I'm going to pull an h out of the top and end up with, what is that, 8x plus 4h minus 3 all over h. And now I can cross the h's out. And at this point, when I plug in h equals 0, I'm not going to get 0 over 0. When I plug in h equals 0, this goes away, and my final answer is 8x minus 3. Again, may not have been a fair question because we hadn't done a problem like this before. But notice if it says h goes to 0, basically you treat the x's like a constant, so you're fairly certain that you are going to get an x in your answer, because like the h's are going to go away, but the x's are still going to stay. All right, next on the list. I think I had 12. Right? Let's see what 12 looks like. Yeah, that's related to the trig stuff. All right. Okay. So as far as trig stuff goes, I don't know a thing about cotangent. I don't. In fact, the only thing I talked about yesterday was I talked about like sine x over x, and I talked about something dealing with cosine, but I didn't say a thing about cotangent. So since I didn't say a thing about cotangent, we don't know how to deal with it. So what we're going to do is change it. So I'm going to change this. I'll say this is the limit as x goes to 0. Cotangent, that's going to give me cosine of 4x over sine of 4x. And cotangent of 3x is going to give me cosine of 3x over sine of 3x. So step one, right now, the only thing you know how to deal with limits with trig functions is pretty much just with sine. All right, and I don't like this whole layered stuff. So to fix this, we're going to go and say, all right, we're going to do the limit as x goes to 0. That's going to give me cosine of 4x over sine of 4x times, and I get sine of 3x over cosine of 3x. Now, here's the trick with trig functions. Whenever you have everything all bunched up, I see 4 trig functions. I'm going to break it apart. I'm actually going to make it 4 separate fractions. I'm going to make this, technically I could do 3, but just so some people like rules for everything, so I'll just break it up into 4 trig functions. So that's going to give me the limit as x goes to 0. It's going to give me cosine of 4x over 1 times 1 over sine of 4x times sine of 3x times 1 over cosine of 3x. Now, at this point, I'm just going to plug in 0 and see what happens, right? Because some things work out okay, some things not so much. And remember kind of our rule, cosine of 0 is 1 and sine of 0 is 0. So when I look at these fractions, things that I can handle, like if I plug 0 into this, well, 4 times 0 is 0, and cosine of 0 is 1, this becomes a big fat 1. The sine, I can't handle those right now. Dividing by 0, this ends up being a 0 over 0, and I can't handle that right now. But if I look at the last one, cosine of 0 is 1, so this becomes a big fat 1. Now let's talk about what happens here. Our rule is, I can handle sine of stuff over stuff as long as the stuff is going to 0. And if I have a 4x here, I need to have a 4x up here, and if I have a 3x here, I need to have a 3x here. Well, the numbers I can do. I can multiply top and bottom by 4, or top and bottom by 3, and that's fine. The x's, you got to be, the clever trick we talked about yesterday was I'm going to put an x on top and an x on the bottom. Because algebraically, this is still the same, right? Because those x's would cancel out. But now that I have my x, I can multiply top and bottom by 4. And this, I can multiply top and bottom by 3. And our trick is, so the limit as u goes to 0, is anytime you have sine of stuff over stuff, this becomes a big fat 1 as long as those are going to 0. Well, these are going to 0, so this becomes a big fat 1, and this becomes a big fat 1. And what's left over is the 3 over 4. Okay, so that's 12. Wow. Then, let's see, a lot of people are interested in, what is it, 22. All right, let's see what 22 looks like. Oh. Shoot, I didn't mean to assign that one. I haven't taught how to handle as it goes to infinity yet. So ignore 22. Because we have not talked about limits as stuff goes to infinity. Let's see, 25 and 26. Let's see what 25 looks like. It's probably at the top of the page, but of course it is. So whoever asked about 25, I'm glad you did. And here's why. Okay, when you plug 9 in, let's see, looks like I get 3 over 0. What's happening? Like, this is not an indeterminate form. Anytime you get number over 0, you can tell me what's happening. Hey, if it's 0 over 0, that means you got to do more work, but I got 3 over 0. I don't have to do any more work. I should be able to know what my answer is at this point. And anytime I get 0 on the bottom, that means I get a vertical asymptote. Oh. forgot to do 17. Sorry, I'll go back. So since you have a vertical asymptote, you have two options. One option, and the safe option, is I've got a vertical asymptote. I can just go ahead and say it does not exist. I think Calculus Maximus, when you look at his answer, what he realizes is that everything's positive. So like this picture, even though it has a vertical asymptote at 9, both things are going to positive infinity. And since both things are going to positive infinity, he has an answer of positive infinity. But I would take does not exist. And let me get back to 17. Somewhere over here. Yeah. Ah, yes. Good question for 17. Close that little window out. All right. So first, I like using Greek letters. Seems like everybody, anytime you use trig functions, they like using Greek letters. Kind of a funny story. I grew up in Atlanta, and actually, I don't have time. My trig teacher had a very southern accent, and the first time you see Greek letters is usually in your trig class. So since she had a southern accent, she pronounced them alpha and beta and theta. Right? Well, if that's the first time you've heard it, that's what you think they're pronounced. And so there were kids that were transferred from New York, had strong, northeastern accents. They would leave class talking about sine alpha and cosine beta. And I'm at my desk going, no, it's alpha, beta. All right, anyway. So, meanwhile, back at the ranch. If you don't like theta, you can change it to x. If you think about this, I want you to think of that sine cubed as 3 sines. So this is really the limit as theta goes to 0, and then go ahead and write it as sine theta, sine theta, sine theta. And in a similar fashion, I want you to think of that theta squared as, well, it's a theta times theta. So I'm going to put a theta here, and this whole thing I'm going to stick here. 1 plus cosine theta. Now, once we've broken it up where we can handle it, because this is all we know, right? We don't know how to handle sine squared over something. We know how to handle sine something over something, right? So all the squared things, we just break it apart. Now when we look at it, as theta goes to 0, there's your big fat 1. As theta goes to 0, oh, there's another big fat 1. As theta goes to 0, well, sine of 0 is 0. And on the bottom, let's see, cosine of 0 is 1. And so that gives us a 0 over 2. And I know 0 over 2 is a big fat 0. So 1 times 0 is 0. Okay. Let's see, 14. Okay, same thing. We don't know, and this is a trick you're going to use frequently as we start doing more algebra things. Anytime you see a fraction, if you've got a single term on the bottom, break it apart. So if I give it to you like this, it looks confusing. But had I written the problem as, what's the limit as x goes to 0 of 4x over x plus sine of 2x over x? Well, let's see. 4x over x, let's see, the x's cancel, so that just gives me 4. How do I handle sine of 2x over x? Well, I need these to be the same because they're going to 0. So I'll make a 2 in the bottom, multiply top and bottom by 2. There's your big fat 1. And so now I end up with 4 plus 2, which gives me 6. Did I do okay with 14? All right. Let's see. 17, well, I've got a pile of questions. Let's see. And then we've got 26 and 27. 22. Let's see what 22 looks like. That's the infinity one. Yeah, I can't do that one. I didn't mean to assign that. 20, 25 and 26. Already done that one. So that particular one, why is it 14.8? Because you're adding. It's this plus this. Yeah, I'll post the answer key in Content Library in OneNote. Okay. Let's see. Let's look at, 25 I've talked about. I do want to talk about 26. Again, this is one of those things, it's not, I didn't get a chance to explain a ton of it, so if you had trouble with it, you have every right to have trouble with it. So before this one, before I do this problem, I want to talk about what do I want to talk about? I'm going to talk about sort of an intro problem to this. So let's talk about what's the limit as x approaches 2 from the right of x minus 2 over x minus 2. I was rushed at the end of class yesterday. Let's talk about this for just a second. And if you're talking about this limit, anytime you see absolute value of stuff over stuff, the instant, whenever you see this, I want you to think it's this picture. Okay? What you have is absolute value of stuff over stuff. That creates, there's 1, there's -1. We get a line this way, and we get a line this way. If you don't believe me, you can just plot points. You can think of y is equal to the absolute value of x minus 2 over x minus 2. If you're above 2, you're going to get the same thing over the same, you're going to get the same thing on top of each other, so that's going to cancel out and give you 1. If you're less than, oh whoops, that's not here. Our breaking point's at 2, so we have this. So here's 1, here's -1. So if you've got, with this, if you plug in values, if you plug in anything above 2, you're at 1. If you plug in anything less than 2, you're going to get a positive number over the negative of the exact same number, so it's going to give you a -1. So this picture, this graph is this. And if I want to know what's the limit as x approaches 2 from the right, well, if I know that's my picture, that means this is approaching 1. Okay, fine. What happens if I change it? What if instead of this problem, I make it this problem? All right? Now, there's 2 ways to look at it. One way to look at this is, well, what does the graph of y equals absolute value of x minus 2 over x minus 2 times 3 look like? Okay? Yeah, you could just plug something in greater than 2. Yes, but I want to talk about what happens when there's an x, so sort of a generic view here. All right, so when I say, what happens when I multiply times 3? Well, one is you could think about how does that change your graph? And to be honest, how it changes your graph is instead of going to 1, it goes to 3, and then it goes to -3. So you have pretty much the same graph, but instead of the lines being at 1 and -1, they're now at 3 and -3. All right, fine. That's one way to look at it with a graph. But here's how I'd like you to think about it. How I'd like you to think about this is we know what, start circling things that you know what's going on. So like in this particular problem, I know that this is either going to be 1 or -1 depending on what direction I'm going in. Like I know what this is because I know that graph is here. So I know this is either going to be a 1 or it's going to be a -1, right? And since we're coming from the right, I know this is going to be a big fat 1. And now this says take whatever this is and multiply it times 3, so I get 3 times 1, and so my answer is 3, which, you know, just like Sophie suggested, couldn't we just plug in something a little bigger than 2? Yeah, if you plug in something a little bigger than 2, you're going to find out your answer is 3. All right? But now, how does it change if instead of calling that a 3, I call it an x? How do we approach this when it's an x instead of just a number? Well, I'd rather not graph this because graphing it's going to be a bit of a pain. But what I can do is look at this and say, well, I still know that this is going to either 1 or -1. Since it's coming from the right, I know this is a positive 1. Then I just have to figure out, well, what's this doing, right? Another way of thinking about it is, this is really the limit as x approaches 2 from the right of x times the limit as x approaches 2 from the right of x minus 2 over x minus 2, where we already know this is a 1. And now our job is to figure out what this is, and then whatever this answer is, multiply it times 1. Well, what's your limit as x approaches 2 of x? Well, plug in, remember we're looking for a y value. If I plug 2 in, my y value is going to be 2. And so I end up with 2 times 1, which gives me 2. Okay. Now, how does that help us answer this question? Well, hopefully it makes it really easy. Because when I look at this, what I see is something that I know and then some leftover stuff. See, I know this, right? Anytime I see absolute value stuff over stuff, I know that's either going to be 1 or -1. Since we're coming from the right, I know this is going to be a big fat 1. Next, I have to figure out what this part is. Well, as x approaches 2, what's x cubed? X cubed is 8. So I end up with 8 times 1, which gives you 8. Did that part make sense? It's the same thing, because the graph is the same. If I were to graph y equals the absolute value of x minus 2 over x minus 2, if I were to graph this in my calculator, I would get this picture. If I were to graph y is equal to x minus 2 over the absolute value of x minus 2, I would get the exact same picture. And since I get the exact same picture, your limit's going to be the same because remember the limit is based on the picture. Okay, let's see, what's next? Oh wait, so someone commented about one of the trig ones where they pulled a 4 over 3 out. Okay, so reference back to this problem. This is why I'm making you show work. Let me come back up here. Shoot, where was that? Probably way on up here. Okay. Okay, back to 12. All right. I realize a lot of you can do shortcuts. You look for patterns and you figure out why is he going through all of this. All right, mathematically, you can't just pull the 4 out. Doesn't work that way. Trig functions never work that way. So when I have you show your work, I'll give you 1 point for giving me the right answer, but I won't give you any other point because I won't give you any other credit because this isn't. You can't just factor out a 4 over 3. Trig functions don't work that way. Is it a pain? Yes. The problem is I've got to kind of hold the standards that they would do in college, and there is no professor that would just let you factor that out because trig functions never work that way. Okay. I think the next one I've got is, let's look at, someone asked about 30. Shoot, did I assign 30? I don't think I meant to, but I do want to talk about it. You won't have anything like this on your quiz, but I would like to talk about it. Because it might show up on the AP exam. This is effectively your okay. Oh, 27. Keep asking about 27. Why aren't you doing it? Yeah, I'm avoiding it. All right. So 27. So this is one of those things where there's no algebra that you can do. So this is saying, what happens as we approach 3 from the right. The first thing we do is we plug in 3. And if I plug in 3, let's see, that gives me 3 minus 1 over 0. All right, so that's a 0. I'm okay with that, and I get a negative. All right, this is not an indeterminate form. Right? Number over 0 means you've got an asymptote. The way I want you to think about computing limits, particularly when you get a 0 on the bottom and a number on top, is you have an asymptote. And if you have an asymptote, you should be able to tell me what's happening. Now, in one of the previous cases, I just said, what's the limit as x? If I just said x approaches 3, you could say does not exist, and we're fine, because pretty much when you have an asymptote, when I ask for the complete limit, it doesn't exist. But this time I'm asking, what happens if I'm approaching from the right? So here's our situation. At 3, I've got an asymptote. I know I've got an asymptote because I'm dividing by 0. Anytime you divide by 0, you have an asymptote. Now, you have to tell me, where am I going? Am I going up the wall, or am I going down the wall as I'm coming from the right? And how do you do that? Well, I'm not really drawing the graph. I'm drawing this to say this is the picture that's in my head. Okay? So you're sort of acknowledging, because you're dividing by 0, you're acknowledging there's a vertical asymptote. And now, once you've acknowledged there's a vertical asymptote, you have to say, well, where is it going? How do you figure out where it's going? I plug in something a little bit bigger than 3, and it's not as tedious as you might think. Like I'm going to say, what happens if I plug in 3.1? And if I plug in 3.1, here's what I see. Like, what happens if x is equal to 3.1? Because all I want to know, am I going all the way up or all the way down? If I plug in 3.1, I end up with a positive number. That means I'm going all the way up. If I get a negative number, that means I'm going all the way down. So if I plug in 3.1, well, 3.1 minus 3, that's a positive 0.1 minus, and if I plug in 3.1 here, that's going to give me 1 over a really tiny number. Now, this is dealing with number sense. 1 divided by a really tiny number, this number is going to be very big. But then I have small number minus big number, which tells me this is going to be a pretty big negative number. At this point, I know it's going all the way down. And so that's, as far as when you're computing limits, right, plug in something, once you know you've got an asymptote, plug in something to whatever side, and if you get a positive number, it means you're going all the way up. If you're getting a negative number, you're going all the way down. If you're worried about the quiz tomorrow, this is a little uglier than I would put on the quiz. So back to 30. So how 30 works is it's really just it's a squeeze theorem problem. How do I know it's a squeeze theorem problem? Because you've got a function in between these two things. Now, this is asking, what's the limit as x approaches -1? I don't know if you noticed, they don't tell us a thing what f of x equals. All they tell us is, this is always bigger, this is always smaller. What's happening to f? Well, and actually, they don't even know what's happening at f everywhere. They just want to know what's happening to f at -1. So over here, if I make x equal -1, when I plug a -1 in, let's see, that's 1 minus 2 plus 2 at x equals 1, x equals -1, this is basically a 1. And this is a 1. Now, here's our picture. You have the graph of 1, so you have this, here's your lovely red line at 1. Here's at -1. We get this little parabola, which I'm assuming is going to look like this. And then we have f of x, which is doing its own thing, but at -1 it gets squished here, so that it's at a height 1. And so my answer to that is 1. But again, you don't have a question like that in your quiz. I've seen like a multiple choice question like this on the AP exam, I think 5 years ago, but I haven't seen it recently. All right, have I answered all the questions? Let me see. I've answered 26. Yeah. All right. So any questions on homework? Questions similar to the quiz? Oh, I haven't done 27 yet. Oh, I already did 27. What was 27 was I just talked about. As far as what's on the quiz, it's going to be a kind of the basic of what we've done. Anything that I've given, particularly if I've gone over in homework, you're going to have to solve. You're going to compute limits. You'll have to multiply by a conjugate. You could multiply by a conjugate. You could get a common denominator. Definitely you could factor. There could be a trig problem. You could have a limit with a picture where I give you a picture. All right. So those are, as far as level of difficulty, a quiz only counts 0.2. Doesn't count for much. We're not making the quizzes. This quiz isn't, the intent of this is not to be super challenging. It's just, can you compute a limit? And I would sort of estimate that these questions are harder than what's on the quiz. Yes, I said it was 4 problems. So this is sort of an experiment as far as how do we give a quiz, how do we get answers. So it'll be in forms. So I wanted to give you more of I wanted to give you a calculus question in forms, but it's a bit of a pain. We're going to make it up. You will have calculus questions in forms tomorrow, but it was I ran out of time this morning, so I said, well, at least I can give you something where you have to type in forms. Raise your hand if you're able to. I mean, I can check because it'll show up. How many of you were able to do enter your answer in forms? Okay. So tomorrow, what kind of the intent is, I think we'll start at the beginning of class. It won't accept, I have a definite start and a definite stop. So like it won't accept answers if you try to submit before the start, and it won't accept answers if you try to submit after. So we're going to have deadlines. Now there'll be, the intent for this is pretty generous deadlines. A lot of these questions, if you know what you're doing, are easily answered in under a minute. I think our time limit is we're going to give you 5 minutes per question. We want to see the work. So the last question will be upload a file, and then we'll give you 5 minutes to upload your file. So if you weren't, and There's actually two places where you could see the form. This particular one I put in the post, but I think a faster way is in the assignment tab, because that's where I created it. I'm trying to think if there was something on Khan Academy where you can get some extra practice. But this one, the quiz that we're giving you tomorrow is significantly easier than the quiz we gave over this material last year. I know there's a lot to process. So where I will put the answer key to homework, I'm waiting till the end of the day, but I will put the answer key in OneNote in Content Library. In the Content Library, I will create a unit called Unit. I'll create a tab called Unit 1, and in Unit 1, that's where I'll put answer keys. So I haven't had to put answer keys with anything we've had so far because it's been out of the book, where you can find the answer in the back of the book, or on Calc Chat. Khan Academy, it gives you the answer. With Calculus Maximus, yes, I do want you to see the answer. So I'll put the file in the content library. I don't like doing it the day of homework because I have students that'll just, if you look at the answer while you're trying to do it, I don't think it's not as effective as trying to do all of the problems and then after you finish the problems, checking. It's too easy to look at the answer and say, oh, that makes sense, and then copy it down, as opposed to trying to create it on your own. So I'll give you the answers, I just don't give it to you the same day that I give the assignment. All right, any other questions? Yes, I think the answer key will be in Content Library. That's where I stick answers to things. Yeah, so, oh, whoops, wow, this is one giant run-on sentence. Probably should have, need to cut